So we are from group Ifwat, Fridaus, Fremmy and Ainul. We were gonna present a simple video presentation for question group 2. So it is given that a solution is poured off at a constant rate of 100 cm3 per second into an empty inverted conical container with a radius of 20 cm with height of 60 cm. The solution height H in the container is 3 times of its radius. So what we can see from the question is it is given constant rate of 100 cm3. So it was a volume per second. So we have dV over dt equal to 100 cm3 per second. So let's go to the next. It is given that it was filled into empty inverted conical container. So it's like inverted conical container, and it is given that the radius of the conical container is 20 cm. So R equal to 20 cm. And the last one is about the height. The height is about 60 cm H. So it is also given that the fluid is about the solution height H in the container is 3 times of its radius. So we consider it is the fluid, and the height was 3 times of its radius, so it's 3 times R. Okay, so we're gonna do question A. So calculate the rate of change of the surface radius. So we know that it wants surface radius, it wants dr per dt, because the rate of change is equivalent to the times. So what we gonna do is we need to search about the dr over dt. So what we can get from dr over dt is about the, firstly we gonna write dr times over dt. So what we gonna do is about the dr over dv. The next one is about dv over dt. So when we can get dr over dv, so we need to derive from the formula v equal to pi r cube, because it was stated that it used a conical flask. So when we gonna differentiate it, it is become differentiate r, it is become dv over dr equal to 3 pi r square, because we have to differentiate it. So how we differentiate it? So the power we gonna go to the in front, so it is become 3 pi, we gonna copy r, and the power of 3 we gonna minus 1. Okay, so it will become 3 pi r square. So but the question wants dr over dv, so we just split dr to the top and dv to the bottom. So dr over dv, it will become 1 over 3 pi r square. So from the equation that we just, from the formula that we just make, we just copy again dr over dt equal to dr over dv times dv over dt. So we get our dr over dv, that is 1 over 3 pi r square, and the dv over dr is 3r. So from this equation, what is 3r? R means the radius. So we gonna go through to the next one. dr over dt equal to dr over dv times dv over dt. So the r is stated in this question is 10 centimeter. So I'm sorry, this is dv over dt. Okay. So for the solving problem is dr over dv, we get 1 over 3 pi r square times dv over dt, that is 100 centimeter. 100 that we get from the equation dv over dt. So we can conclude that 1 over 3 pi r, it is state on the question that is 10 centimeter. So we gonna instead is 10 square times 100. So the answer for dr over dt is 1 over 3 pi centimeter per second. That's for question A. Okay, so for the next question B, given that the volume of the solution in the conical container is V equal to 1 over 27 pi H cube, find the time taken to fill the container completely. Use pi equal to 3.142. So for the V, we got the volume V equal to 1 over 27 pi H cube. So we got dH is 60, right, from the question. We derive from the question. So we just make it 1 over 27 pi times 60 cube. So at the last, for the V, we got 8000 pi centimeter cube. But it says we gonna find the time taken. So we need to make a formula that is V over dV over dt to find the time taken. So equal to 8, the V is 8000 pi centimeter cube over dV over dt. We got from the question that is 100 centimeter cube per second. So we just make the answer that is 80 pi per second. So 80 times the pi that is given, 3.142, equal to 251.36 seconds. So the time taken to fill is about 251.36 seconds.